Now we are going to look at various carbon compounds. We are going to start with the simple organic compounds. Hydrocarbons. They are called hydrocarbons because they have only two elements, carbon and hydrogen. The smallest hydrocarbon is methane, then ethane, propane. The list goes on such that you can add one carbon to get the next one. Methane has the molecular formula CH4 and ethane has C2H6.
So we will see how exactly these compounds are formed. Here we will form methane with one carbon and four hydrogen atoms to form its ball and stick model. The speciality of this structure is its pyramidal shape. Thus, we obtain the structure CH4. Now, if we remove one hydrogen, it forms CH3, which is an unstable compound as all the valences of carbon are not satisfied. To satisfy the same, we can form carbon-carbon bond, thus forming the compound ethane, whose molecular formula is C2H6. Further replacing the hydrogen with one more CH3 and forming one more carbon-carbon single bond, we obtain propane with chemical formula of C3H8. Adding another CH3 gives us butane with formula C4H10. We can go on adding CH3 to form new compounds.
Let us start writing the line structure of ethane. Draw the two carbons. Each carbon needs to form 4 bonds. So we then fill the valence using the carbon-hydrogen bond such that each carbon has 8 electrons in order to satisfy the octave rule. Do the line bond formula looks like this. Now if I want to draw the loose electron dot structure of the same molecule, I need to understand that each of these bonds is formed by overlap of 2 electrons such that these 2 electrons are shared between the 2 elements. In case of carbon-carbon bond, each of the carbon is donating one electron, and the same happens when they want to form bond between carbon-hydrogen. You can see that the electron dot structure of ethane is like this. You can try drawing line structure for propane and butane. If you see this type of molecules of ethane, propane or butane, it seems that valences of all atoms are satisfied with just single bond, and such compounds are called saturated compounds. Converse to that, you also have unsaturated carbon compounds which have at least one double bond, more than one double bond or even triple bond. Saturated hydrocarbons with all single bonds are called alkanes. Let us look at unsaturated compounds, ethylene, which has the molecular formula C2H4.
Looking deeper into this, we have ethylene or ethene over here with chemical formula of C2H4. Now, we will repeat the procedure of replacing hydrogen with CH3. We will obtain propene whose chemical formula is C3H6. Again, replacing with CH3, we obtain butene. The chemical formula of butene is C4H8. Just like saturated hydrocarbons, we can go on adding CH3 and form numerous compounds.
If we try to draw the structural formula, carbon and carbon will first form a single bond. Then I will satisfy the carbon-hydrogen bonding such that there are 4 hydrogen atoms. So I will draw 2 carbon-hydrogen bonds attached to each. 2 carbons have only 6 electrons around them. Carbon needs 8 electrons to complete its octave. So we will draw one more bond between carbon and carbon. That is a double bond. This will be the line structure. If I have to look at the electron dot structure from the line structure, it's quite easy. Each of the carbon-carbon bonds is going to be formed with 2 electrons each. Carbon and carbon have a double bond. They will have 4 electrons between carbon and carbon. Each of the carbon-hydrogen bond is a single bond. There are 2 electrons in there.